Hi, I'm Todd Beavis, and I'm the engineer and fabricator here at Cagnazzi Racing, where we build NHRA Pro Stock cars that travel in excess of 210 mile an hour. The tubing you see behind me is all 4130 chromoly. It's the mandated material used for NHRA Pro Stock drag race cars. The tubing size used here is anything from 1 5/8 83 wall to as small as 1/4 inch and as thin as 35 wall. So the fit and the finish and the attention to detail on this is paramount in all that we do. The fit on thin wall, small diameter tubing is so important in that it determines how much heat is going to be put into the weld. If I have a fit that's not very good and I'm having to use a lot of filler rod and a lot of heat to get it to bridge the gap, then I'm risking the possibility of embrittlement around the weld area because of the heat concentration. So we try to make the fit as tight as we can without creating any gaps, so we can use a little less filler rod and accomplish the same goal. Filler rod typically goes with the size of the weld that we're doing. If I'm welding on something that's 35 wall, I'm going to use a 30 thousandths rod or a 40 thousandths rod. If I'm welding something that's in an 83 wall or a 65 wall moly tubing, I'm going to use typically most of the time a 63 or a 1/16 welding rod, sometimes a 3/32, depending on the thickness of the tube. The heat's controlled by a foot pedal. Now, there's a general rule of 1 amp per thousandth of material thickness. So let's say I'm welding 65 wall tubing, I'm typically going to be on about 65 amps on my welder. But it's also controlled with a foot pedal that's a rheostat, so I can, like a gas pedal in a car, I can give it more power or less power, and which in welding terms would be more heat or less heat. But that's also affected by how fast I weld or how slow I weld. The slower weld at a same amperage setting is going to be a hotter weld because the heat is dissipating into the material we're welding. Arc length is the distance from the tungsten to the piece that we're welding. And with chromoly in TIG welding, we want to keep that arc length as small as possible without contaminating with the welding rod or touching the puddle that we're trying to weld. As the arc length gets further away, it requires more power from the welder to push that arc off of the tungsten onto the weld. So therefore, you get a bigger spark and it's spread out wider, and there again, it's going to spread the heat. And welding chromoly, we want to concentrate the heat in a small area. When you're welding, I try to tell people I've taught how to weld that it's like a signature. Whatever happens in the hand that you're holding the torch with is going to come out on your work or the weld that you're producing. So there's two different methods I try to teach you guys. You can either use what I call a sewing machine method, where you kind of put a dab of weld and then you move, and you put a dab and you move. And the movement may be like a 1/16 of an inch or so, or an 1/8 inch, depending on what you want a weld to look like, because it's going to reproduce what your hands do. You can also take and do very small weld real smooth and feed the rod real smoothly, and it'll leave a more smoother machined looking weld as opposed to welds stacked on top of each other. So that is going to become a signature. Whatever, it's like writing in first grade. They give you a big pencil when you first start out, it's a little squiggly and sloppy, but as you practice and you get better, the welding will get better, and then your weld become your signature in what you weld style is.